You know, when you picture a high-tech lab, you probably imagine all this gleaming, complicated machinery, right? But in the middle of it all, there's usually this simple box, an often ignored workhorse that, believe it or not, makes so much of that science possible. Without it, a ton of the world's most important discoveries just wouldn't have happened.
So here's a question for you. What do you think connects a forensics team trying to lift fingerprints off of evidence, a materials engineer who's creating the next generation of electronics, and a biologist making sure their experiments are totally free from contamination? It's a great question, right? Well, they all depend on one surprisingly simple yet incredibly precise tool.
And here it is, the laboratory oven. Look, I get it. It might not have the cool, futuristic vibe of a gene sequencer or the mind-boggling complexity of a mass spectrometer, but its job in the lab, it's just as critical. This thing is truly one of the unsung heroes of the scientific world, providing that perfectly controlled heat that so many experiments rely on.
So, what is it really?
Well, at its heart, a laboratory oven is a high-precision heating chamber.
But please, don't confuse this with the oven in your kitchen. These things are engineered for pinpoint accuracy and incredibly stable, uniform heat. We're talking sometimes over 300 degrees Celsius, all to make sure that every single part of a sample gets the exact same thermal treatment.
And the versatility is just incredible. I mean, in a single day, a lab might use one of these ovens to gently dry out some biological samples, then crank it up to sterilize glassware for a sterile culture, cure some advanced polymers for a new device, and even anneal metals to change their crystal structure, making them stronger. The range of what you can do with it is just immense. But, and this is a big but, not all lab ovens are created equal. You gotta have the right tool for the job. So let's take a quick look at the two most common types that you're gonna run into. Okay, so it all comes down to one simple thing: how the air moves. On one hand, you've got forced convection ovens. These use a fan to actively push hot air around, which is perfect for really fast, super uniform heating. It's basically the same idea as the convection setting on your oven at home. Then you have natural convection. This type just relies on the fact that hot air rises. It's a much gentler process, which makes it ideal for things like fine powders or delicate samples that would just get blown all over the place by a fan. And here, you can actually see what we're talking about. On the left, a pretty standard-looking oven. But on the right, that's the key. That fan is what makes a forced convection oven so effective. It is constantly moving the air to get rid of any hot or cold spots, making sure the temperature is perfectly uniform from top to bottom. And that is absolutely critical if you want reproducible results. You know, making sure your experiment works the same way today as it does tomorrow. Now, before you even think about turning this thing on, there's something that's totally non-negotiable: a proper pre-use inspection. And listen, this isn't just about getting good data. This is about keeping you and everyone else in the lab safe. So think of it like a pilot's pre-flight checklist for your experiment. You've got to make this a habit every single time. First, just give the power cord and the outlet a quick look for any fraying or damage. Second, check the door seal. If that seal is cracked or brittle, heat is going to escape, which ruins your experiment's accuracy and creates a hazard. Third, glance inside and make sure the shelves are clean and locked in place. And finally, just make sure the little temperature sensors aren't blocked by anything. Simple. Okay, so our pre-flight check is done and we are ready to go. Now, the control panel can look a little intense at first, but once you know what's what, the main functions are actually really simple. Yeah, I know. This panel can look a little intimidating with all the buttons and lights, but honestly, for most of what you're going to do, you only need to worry about two main settings: the target temperature and the timer. All the other keys are for more advanced stuff. But that digital display, that's your best friend. It's always going to show you the most important piece of information: the real-time temperature inside. The actual process? It's really straightforward. You just power it on, use the menu to dial in the temperature you need, and set a timer if you have to. Then you load your samples, and we're going to talk about the right way to do that in a sec. Close the door nice and tight, and just let the science happen. Okay, I want you to burn this number into your brain. 70%. That is the absolute maximum surface area of a shelf you should ever cover with your samples. Why? It's all about airflow. If you overload the shelves, you block that air from circulating, creating cold spots and meaning some of your samples won't get heated properly. It's one of the easiest ways to completely ruin an experiment, so always give your samples room to breathe. All right, let's shift gears and talk about the most important part of this entire explainer: safety. A laboratory oven is a powerful piece of equipment, and it absolutely demands your respect. Following these rules isn't just a suggestion, it's critical. I really want this next quote to stick with you, because it's one of the most important safety lessons you'll ever learn in a lab. You cannot tell if glassware is dangerously hot just by looking at it. Always, always assume it's hot and always use the proper tools to handle it. Rule number 1, and this is a huge one, you can never put flammable solvents or any combustible materials inside the oven. Period. Heating them up creates vapors that can ignite, and that can lead to a fire or even worse, an explosion. And on that same note, you can never, ever heat a completely sealed container. As the temperature inside goes up, the pressure builds and builds, and with nowhere for that pressure to go, the container can rupture violently. It basically becomes a small bomb right there in your lab. You have to assume that every surface on this thing, both inside and out, can cause a serious burn. And a great tip, when you go to open the door, don't stand right in front of it. Stand off to the side to avoid that big rush of superheated air that's going to come billowing out. Oh, and plastics. You have got to be super careful here. Not all plastics are the same. A lot of them will melt at temperatures that are pretty common in these ovens. And if they melt, they can drip down onto the hot heating elements and potentially start a fire. So always double-check the max safe temperature for any plastic container before you even think about putting it inside. And of course, none of this matters if you're not wearing your PPE. This is your last line of defense. You need a proper lab coat, you need safety glasses or a face shield, and most importantly, you need thick, heat-resistant gloves for handling anything that comes out of that oven. So when you get right down to it, the lab oven is a real cornerstone of science, a tool of incredible precision. But all that power demands respect, knowledge, and a whole lot of caution. The quality of your data, the success of your experiments, they all depend on you using it the right way. But most importantly, so does your safety. So the real question is, are you prepared?